speakers from our own soil, from the Department of Physics also, from DM University also, and NIT also, and so the first is our respected teacher, Shri M. Shomananda Singh, DM College of Science, head of the Department of Physics, and under DM University. So it should start from 9:30, but a bit late. So you please continue, no problem. So I request Oja Shomananda to start things about. So.
Yeah. Thank you. Yeah.
She's not there.
Okay.
She's not. She's next.
Yeah. 계속해. somnante 밤으로 너무 모니터로 이 마땅으로 concentration 이렇게. 그는 시야도 시야다 시기자. later bro 오늘이 이렇게. Good morning to all. Siya Dibra. Tarabra. Good morning to all. Yareko. To all the participants. It's a privilege and to be pleased in this August gathering about the International Year of Quantum Science and Physics. Sadbara. Tarabra. Tare. First of all, with the permissions of this August gathering, let me have a slight moderations about the topic. But it's just a simple manifestation of the previous one, which was earlier published in our programs. And I found this one to be somewhat memorable in the sense it happens to be era of early 20th century, a new dimensions in physics, supposed to be the origin of quantum mechanics. So, in quantum physics, before going into detail about this one, you see, in that era, we and most of the physicists do impose on the Newtonian mechanics, so to say, your classical mechanics, and found some limitations. As everybody or everyone says that no one is perfect. Likewise, in nature also, classical mechanics have some limitations in dealing with certain problems. And the thing happens to be its limitations all over the discussions of classical inadequacies in dealing with certain phenomena, I mean atomic phenomena. Rather to say from macroscopic level to microscopic level. And in the level of atomic configurations, classical mechanics some sort of inadequacies, like the concept of optical spectra, and more generously, the blackbody radiations and photoelectric effect, and stability of atoms and molecules and everything, something like that. And we did with this very concept. Everyone, I mean, the scientists are supposed to be looking forward all about new manifestations or rectifications of the old previous knowledges. And we should not ignore that one also. We cannot refer it to be an ideal, refer to be totally correct or totally incorrect or something like that. Everything should be a level of manifestations of every theories in physics. Even the error can be rectified with new precisions and adaptations. I mean, modifications of laws to adapt the situations, and such thing happens in this case also. And you see, before going into the old concept of your atomic configurations, something like that, you see, the limitations of classical physics arises when physicists turn their intentions to predict all about happenings of atomic scales or microscopic dimensions, and found that, you see, more characteristics of the atomic systems happens to be not defined properly, and could not have the matching of experimental observations with theoretical observations or something like that. And you see, the effort reached their successful conclusions from a period of 1925 onwards up to 1930, when entirely new theoretical concept or aspects or discipline, so-called quantum mechanics, raised up, and which was developed by Schrödinger, Heisenberg, Dirac, and others. And before going into that very period, you see, the earliest evidence of inadequacies of classical mechanics happens to be in the study of the classical concept. I mean, we need to review the classical concept while dealing with the stability of atoms or molecules, which actually raised from the study of chemistry. And by the time, any molecules or material particles which are supposed to be consist of a number of positive and negatively charged particles, and they are supposed to be bind together under the effort of electromagnetic forces. But also, Anson's theorem, this happens to be a landmark while dealing with these configurations or while dealing with these very aspects. His statement said that a state of charged particle cannot remain at rest in a stable equilibrium under the influence of only electrostatic force. Then the situations rather seems to be in a chaotic manner. And by the time, you see, if classical picture is to be adopted, these particles must therefore be in relative motions. And there seems to be, you see, if the particles or system of particles do confine, I should say the charged particles be confined in a stationary, be confined in the stable or be confined in a region under stable conditions, then it has to fulfill some relative versions of their respective configurations. That means, you see, despite the system happens to be or appears to be in stable motion, then it needs to maintain a relative change in configurations so as to yield and so as to idealize this very concept, that is Anson's hypothesis or theorem. And basically, by that time, if charged particles, this is a simple case. If charged particles, you see, get accelerated, then it has the chance or it has readily liberated or release electromagnetic radiations or electromagnetic waves. Then, what about the configurations? By that time, you see, what we think about the stability of molecules or stability of matter happens to be rather somewhat awkward. We are not in a situation to frankly analyze that very concept. And you see, all the physicists by that era, rather in a mess of with this very concept, and think what will be the next consequences. And you see, likewise, and this is all about that one. Likewise, you see, you better to skip that one. No, photoelectric fair or something like that later, brah. Photoelectric fair kumbagi mutang. Yawrengo. Asidi kanoni. Okay. Mamang da sakalo. Mamang da sakalo. Answers. Oh yes. Okay. Let it. So, likewise, some phenomena, well-known phenomena, the optical spectra, black body radiations, and photoelectric effect have, while making explanations or giving explanations of these facts, the well-known classical theory, I should say classical physics, have certain limitations to cope up these discrepancies or something like that, which could not mess up with the experimentally observed phenomena. And the classical view of theoretical concept are rather found to be inadequate. And this rather makes the classical inadequacies in the study of well-known phenomena. And you see, later on, sometimes physicists refer it an era of old quantum mechanics. By the time Bohr, Niels Bohr, with his quantization rule, L means angular momentum should be integral multiples of some universal constant. Later on, it should be named as your h by twice pi, that is Planck constant divided by twice pi, or rather in short, in Dirac mechanics, it should be named as your Dirac constant I squared. In the form of that one, to some extent, the concept of stability of atoms or stability of stationary state can be checked with this quantization rule of Bohr. Bohr quantization rule means well-known L is none other than all the electrons and atomic configurations should have the privilege to occupy it, for which the angular momentum should be integral multiples of h squared or h by twice pi. We are pleased, and all the scientists of that era also happiness with this new invent or with this new discoveries or something like that, or innovative idea, and have the ability to practice more into detail about your macroscopic dilemma or dimensions. And not only that, hand-to-hand comes in the era of Wilson-Sommerfeld quantization rule, which fairly based on the integral, the phase integrals, bring into the manifestations of Cartesian coordinate into positions and as well as, Cartesian coordinate along with the canonical momenta or something like that. But here too, the limitations raise up in the form of, you see, for those periodic systems, for those linear harmonic oscillator, rigid rotator, and everything should be okay or agreeable with the experimental observations. But for those systems which are compatible with non-periodic systems and spin or something like that, again, so to say, the phase integral or a manifestation of all quantum theory again failed to turn off with actual experimental observations. And this is rather the phenomena or chaotic evidences of the era, in the early 20th century. And more and more, all the scientists and all the physicists have the intentions and take it for granted, take it as their duty to rectify the ideal physical laws and that very concept. And hand in hand, the failure of, or I should say, the inadequacy of classical mechanics in the study of the well-prestigious and landmark experiment or landmark theory about your Planck blackbody radiations turned up with the new visions of Planck, Max Planck. You see, by the time all the fellows rather found it to be outward with the characteristics of ultraviolet catastrophe. Was it possible, or is it possible, or what does it mean? They don't have any answer. We, a simple learner and listener, also get confused by these situations. And frankly speaking, in my student's life, I am not able to write the basic fundamental relations or happenings of quantum mechanics by taking into granted all about the inadequacies of physical phenomena, rather awkward. It takes a long duration to understand before arriving the very concept of wave-particle duality. That would be a landmark appropriations or understanding while developing the new era of quantum mechanics. But you see, before going into detail all about that one, you see, after a total failure, I should say inadequacy of classical mechanics in dealing with blackbody radiations in the dimensions of the ultraviolet catastrophe. Now, it should not be sound to be proportionate with the natural idea. And our physics to appraise with nature is someone to even talk about physics is nothing a science of nature or linked with nature. It's a fair adaptations of artistic and as well as poetic form of literature with science, unitions of science with literature. And by that time, Max Planck a faculty in University of Berlin around 1900 or something like that. By the time, he proposed and visualized a concept, energy of an atomic oscillator. By the time, he do emphasize the thermal excitations or thermal energy or thermal excitations of matter or something like that in the form of your blackbody radiations. And the energy of an oscillator is restricted only certain multiples of some natural constant or some multiples of, I should say, I beg your pardon, it should be a multiples of frequency. Means the energy of an atomic oscillator should be an integral multiples of the frequency about which the radiation is supposed to be liberated or executed. And you say the photon of energy or the discretization energy must be your E is given by n height into nu. And your n is a universal, n is an integer value quantity, and height is later on to be termed as your Planck constant, and nu is the frequency about which the energy or the energy of the radiated particle or system happens to take off. And with this new vision, new percept, he turned off a very fair landmark, Planck quantum, I should say, Planck relations for blackbody radiations about the energy spectrum of that particular system. Despite the relations, you see, some way or apparently, by the time we think that a layman think that, oh, energy get to be quantized and we are in the midst of your quantum mechanics. No, the answer is not. It is not a pure picture of quantum mechanics. It rather laying our foundations. But often we refer or regard such development or such innovative idea or discoveries in physics to be the landmark of quantum mechanics or the beginning of quantum mechanics. And the equations itself suggest that the frequency for a system is also enjoys a continuity. It restricted to certain dimensions in the range between nu and nu plus d nu. And of all those continuity of that frequency, we apparently taken out a portion in the form of d nu, means the relative range of frequency nu and nu plus d nu. And about this, you see, the energy should get to be expressed like this. And you see, the energy of that oscillator can be, but one thing, the energy of this oscillator can be discretized by the energy, that is your photon of energy. Later on, B term is your photon. E is none other than n-ized into nu. And with that very concept, you see, the experimental discrepancies, or I should say, the classical inadequacies, rather found to be messed up with experimental observations. It violates the low region, high region frequencies range, means in the form, it violates or agrees well with your religion's propositions and Weinstein's displacement law. It agrees fairly well with this experiment, with this Planck radiation, Planck formula for black body radiations, and have rather seems to be somewhat it activates our knowledge about the intriguing factor of photon of radiations, or I should say the quantized nature of atomic oscillator. Or then the most venerable quantity in all the physics, in all obvious physics, energy itself could be exchanged only in discrete lump or quantized. This is also included in this one, and extensions to this one. If energy is to be get transferred or propagated to another system or something like that, it should be discretized. Not only this one, not only by the atomic oscillator. If certain system or certain energy in physics, exchange of energy and exchange of momentum is just conjugate, is just synonymous to our physics, study of physics. And it's not new to all of us. And not only the discretizations of energy of your atomic oscillator, if a system happens to be prevailed an exchange of energy from one system to another system, it should also get discretized. You see, and with that very concept, with that new concept, you see, everyone quite somewhat plays, but the well-known quantum hypothesis, I mean, E equal to Einstein to nu, or remains to be silent or dormant until and unless the advent of Einstein's photoelectric equations. With this new era of photoelectric effect, with this new concept of photoelectric effect, you see, by that time, the importance of E equal to Einstein nu, means energy for an atomic oscillator happens to be Einstein's times of frequency of that atomic oscillator, have a fair significance in dealing with the concept of your photoelectric effect. And during that time, you see, Rather, Planck, while giving a proper explanations or justifications of photoelectric effect, he visualized and proposed that our light ray or incident light happens to be a stream of photons of energy. Stream of photon of energy. And if an electron or photoelectron is supposed to be excited or supposed to be liberated from the metallic target, only one of your photon of energy should be get use of. And if there arises an excess amount of energy, that very amount of energy should be transferred or should be acknowledged is the kinetic energy of the released photoelectron. And that turns off the fairness of or the real justifications of your photoelectric effect with the Einstein's photoelectric equations. And from the very observations, we readily observe the well-known constant, that is the unique constant, universal constant, that is your Planck constant. 6.625, something like that, 10 to the power minus 34 joules second or something like that. We get the very informations with the new unveiling, with the new discovery of your photoelectric effect, so justified by the use of Einstein's photoelectric equations, which again eventually back off with the concept of your quantum photon of energy, means Planck's quantum hypothesis E equal to I into nu. Then the most, by this time, I think it should be around 1905 or something like that, early 20th century, a quite revolutionary idea in physics. No one agrees, no one disagrees. It should be in a dilemma. We are rather doubtful. All the physicists are rather doubtful. We, the learner and as well as listener, also get confused. Which one is true? Which one is wrong? That is a real dilemma in our brain. And by the time, you see, somewhat have sense and visualize, is it a wave aspect or is it a particle aspect? By the time, you see, in the study of electromagnetic theory, Maxwell also had the proposal that if energy is to be transmitted, it will get promoted or it will get associated with a momentum given by E by C. It's not new to all the fellows, but he doesn't have any right answer to that one without making the knowledge of your wave-particle duality, the wave aspects and particle aspects of the system. What does it mean? There seems to be a quite, everyone think that wave aspects or particle aspect rather seems to be a word, and is it contradictory to each other? But my topic does not include so much all about that one, but we have to place with a very ideal concept that they should be complementary to each other. But wave aspects and particle aspects should be complementary to acknowledge the right configurations for the system. Just for the sake of simplicity, without darkness, no one cannot have the sensation of brightness. Without richness, no one cannot have felt the poorness. Big, small, all are contradictory, not to be contradictory, and we should apprise it to be complementary to each other. And with this very knowledge, we just wind up this very concept, that is, the idea of light carrying momentum was not new. Indeed, Maxwell, this is not new to physicists of that era. And someone wrongly committed that energy, momentum should be E by C. Someone rather doubtful and make our contributions, immense attributions to acknowledge the contributions of our Einstein, the great scientist. But during that time also, Maxwell already proved that, you see, if electromagnetic radiations of energy has to be transmitted or has to be there in the system, then it will have to acknowledge a momentum given by E by C. But you see, this is quite a case of your photons. This is all about the photons from the relativistic concept. Yes, so yeah. I want to come to view now. No, I can only travel. Makaram to view. Was asking she would be going Kangam Maneva. Satra Singh. Was asking in the Teco in Tais. Say, you see, my dear students and young experienced young scientists of our soil happens to be young scientists, I hope so. So, from your relativistic point of view, your E square is given by your C square, then times of P square, then plus of M node E square, then C to the power 4. This is quite common features. It relates the Einstein's relativistic energy. And for a photon, as you know, for a photon, your race mass always, race mass kadowi, delphine and kaurabro, race mass 0 igani. Aduga photon sings get propagated with the compatible speed of light. And with this, see times later on. And after that, you see how much your C, we just ignore all about the negative and positive conventions. Negative energy and positive energy. It will be fairly interpreted through your relativistic quantum mechanics in the era of your Dirac. Dirac lakana tausiko yang wali. Quantum field theory la amdai, then relativistic quantum mechanics la kumatam dadi Dirac ki parang aktani tautusi. Dirac ki magi configuration do koi kawetari tensor from the space time continuum la kumatam da loin thola ni. But I am supposed to take off the idea of era of early part of 20th century. So we have just gone through that era. Koi history oirwa parase koi nahi na seva. Supposed to be turned off in the dilemma of new inventions and new discoveries. Past to yaudana presence koi skelet to bunga moy, which is a direct consequence to complementary principles. Past yaudagari present later moyeba. Present later we say past to libigi later mineva. A real natural phenomena to deal with the complementary idea of nature. So, with this very fact, we come to the knowledge of E is given by C into V, and that's why you see in the light of, it is supposed to be a mixture of your both classical and quantum. And here in this case, S nu N is given by C by V, and from this very fact, you see your V happens to be S by lambda. It's a fair representation of Maxwell's electromagnetic radiations. Electromagnetic radiation to koina disumna Einstein ki photoelectric equation to Einstein ki kai tare se Einstein's extension to Planck quantum hypothesis to adu oina urieba, but rather by that time mano well defined to bangam jadraga su kai lagtare se sigum amalai haibadudi he has the sense or he has the sensations. Okay, so it takes you this one P equal to S by lambda, and someone might get confused. That lambda equal to S by P. That is your well-known de Broglie hypothesis in the context of wave aspects. And this one rather seems to be, classical method never say. Wave aspect low 3. And mathematically, there seems to be no differentiations between these two relationships, but physically, we sense a fair demarcations or fair distinctive features. You see, this one rather seems to be a topic oideko, but making my n extensions to this source. It rather happens to be this one rather this one is motion wave motion electromagnetic wave never say. This one rather seems to be the particle aspects of wave, and this one rather assimilate is the wave aspects of particles. Contradictory way of nature the lady city. matamduda kuina matamdugi irada kuin khangisi nature sidi ko tasini matamdadi lairibis entity ani khuktaneba charge the positive and negative charge lebigum nature si lairimisi we have aspect and we have entity ani khuktani we have and on the other hand particle matter particle I mean manifestations of your particle di matter se ko matter go wave kadang leibidung torameba amaga se interact we have sidi koi tambada yaurte ba koina khanma tamda by the era of your classical mechanics that is early Newtonian period to the koi wave mustn't koi superposed away particle mustn't interact away interactions of particles rather happens to be in line with your scattering problems, in line with your say collisions, regardless of elastic or inelastic. Rather some sort of interactions among the particles. And in a superpositions wave, wave must interact over, particle must interact over city, well pleased or may lower, yasu yagi kui number su pangi ko asum banina dum kui number su dum piri ni ba matam du oja sin loina ewa tori ne nang na tam se sumin la le haide ba kadai da no la le se khanghou da na hauruk pan nong du na hauruk pan nong le mu sit na ko kui kyaw sama tholok pa do no tawre ba physics da madui nomenclature sida ko sagat na ba honok matam da amana amabu thajana de amana amabu warau nei aina puthopasina asumani mana puthopasina aranbani hainingagasu haibang amdagasu haidi hainingeba Einstein gi landmark oiba sorry photon Planck quantum hypothesis ki amna kaite landmark oiba E equal to h nu haibase puthorpa matam da decade long koi adom study tawjana leijraba Rutherford contribution do madu mangba mukna tragasu limitation lakpa religions ki sahi kya mapunsi supama life long when koi sacrifice to puthok char po event me amdu eventuality khudimuk to maman yaudwa malakpa maman yaudwa dinate ko maman yaudwa manba siguma chaotic era ama lakpa matamda another dimensions of physics that is your quantum physics e tholakibani maduna ni koina kaw bangam dadana mabu nusina honor troga saunagi ba meam do loina compliment tawraga ko khudimak pu please to hongibagi ira duni madugi kenu duni khun observe tawjar ise yam phajaba kenu ni message ni piri ibase ahongba innovative idea meam singsina ahongba meam piraga su leiramba ariba khudimak to makoi yaudandadi innovative idea do oini haibase koi lobadu wana thokane haba thokpani masana tabani ai amanba potubu manle hadana hundu uragabu ai anoba ngakta do leibadi ya ponte ba ngasi nauriba idea se matam khari matungda ai khoina chakra matungda su ko chum mena ngangna riba singse kanana khangni ano manifestation lakpa ai khoi string theory gaina khaga hor edana opung phaba phada bududi tongan bo khalamare new extensions to these new innovations in physics or rather in scientific world is immensely appreciated by one and all in the universe. Masana tabani. Akoi thagat pahiba tai. Phajaba mu puthok se aragadi akoi thagat pahibam thokpani. Eko phare masina sumnagi agi views and opinions ni masi thodona koi physics ka mari leina banate. Then hoji sigi idea se koi hai gare ko ai photon sing se si photon gi ai naga sai pi hiba concept to ngasai your E is given by your P is given by H by lambda and haibado H by lambda se masi photon gi kenoda case applicable oipani nai photon gi case applicable oire then matam da ko sigi substitution se yam simple way these particular equations rather some be sigi kanu se yam simple way ba mana logic se yam simple way ko ying matam da substitution se even yam phagi male yam hectic way ba dugumba yam da extensive ba mathematical kanodo oidragasu yako magi depthness leba adugum yam intriguing ba adugum kano madi sense madi koi khudimuk da fawhol le madu yamba precious ba kanodo magi kano haitare se value do madu bune khuna just tawjari bas magi kano se lui na to bune te ba adubu yeng madu samjaraga su ko mon man pire impact si so much wonderful ko anade si matang sida ko breakthrough ama lakture matamdra ko photons kun haire in the light of your in context with your photoelectric effect based on Einstein's photoelectric equations. Photons, we suppose that and we acknowledge that, and Einstein made an assumption that and proposed that light is nothing but a stream of photons. Stream of photons. And if photon is to be, or energy is to be transferred or propagated through a medium, it has to experience some certain amount of energy, and that very amount of energy is almost compatible with that with this one. That is your momentum. I should say momentum should be I spy lambda, almost compatible with that of your Einstein alone view to Maxwell concept and say managum tore. Doesn't money have a dingum there. Mananadi tool eva. Matum to the co. Quiggy. Master show conclusions of people on the letting Isida. Compton gi. Compton tole. Yam Hazaba scattering phenomenon lower, that is Compton scattering. Which signifies, you see, the photon do behave as particle. Not to photon is a particle. Photon can have the chance to liberalize as particle. Photon, I would say, particle aspect. Amagumna visualized to say, yamna landmark of experiment. That is your say the Compton effect. I mean, Compton scattering. Madagiri say we. All the physicists found a new concept that is your photon do behave as particles. The wave aspect about later wave aspect in the particle aspect lack photon. Adu young learners no the wave aspects and particle aspects rather seems to be the contradictory. They should be complementary to each other. And I don't want to assume say among the simultaneously quick with say a raise of Tobum Deba. I know with the two in Hagibudo in the Tapomatonda, I give Mangda lady wishing say, I give Satriam Yawi. I beg a pardon. Go. Makwida in a Hagi, in a queen among the living with particle duality talakotum, in a Hangi. Who am I? Sir, you are our teacher. Then, in the midst of our family, in the midst of my sibling, who am I? Sir, adudi sardi father oire kaino phagi tore yang. Likewise. Nasagi entity to di sama na yeba. Amukata neba. Magi manifestation to di. Nang emo ay hoji ngune ay hoji ino koi the scientific talk se share tori ne dana haibo hitoi ngangi sinda. Ay family gi kaino pusal ya ponte ba. In a family limit the Ayango Tabak para Sakeba. No antituna Sweden Sorkin can go and no less to Eva. Anno, where aspects and particle aspect have say, must be go complementary ni Adua, Mohis Amukta simultaneously utopia de. I am artistic way hidden as you, Aina Lila Yauraga, Lila to the physics tak Piaroi. Aina class Manula Recande Lila to Piaroi. Anno, likewise. Complementary di win a gadavani, lady by entity to di Masak Mam Ponteva. I know quantum mechanics to make up Tokibasi. Aye, how crabba, worry meaning Sangake, in an aquidona satra, we get young away quantum mechanics, Pambam Jukang dico, Mase, Katase, Pura, Handu, Sinbite and the Tolopon of the neighbor. Sinbite data, really speaking. Carino, Singoi Sulakan had the soy beneath the high air. Singoi Siluga soy beneath Harry, I caleba, Imanabakara, Vivacious of Iman of the High Giba, Sar a soy visicadutum dunun. Sar Rasputin, Nushi, Manuli, a mariner not Rasput and a clay, I put a beer. Yam Pazanahi, concept yam summi, Manahai. Aran Bussing say, a soy bussing say, Tiri at Sumbalak Twini. Hek Polak Padan Koibu Herik Prane, Tamatamaga, some, no quasi, some. Same here Indian high ever go. Aduning sang e. Aduna, come on together. Yanan bada Kangdi, Mana was Adunang bada Isekara, Tagan Malurabra, the would mean man the Labani Kituki Urubra Kangdiko, eternal loan canoni, attend going Manipur eternally. But on the man Mr. Singh is electron a wave or particle complex Kangzani. Is electron a wave or particle hybrid? But on the sing, I was a quick sing and away. I'm an Amrisardagi, Quiggy, Premises sing in Amaga. I know Shomananda Singh na leisredana ibani to many ni kuigi conference hall haigada kuigi kano se gallery de sibe to many ge adagidi ozadu khanga mane ozan haire what I mean to say is Mr. Singh from Manipur and haire imana do yam harau na madi non dhagreba ai se I gyan ta dan ai haugal e tapna haugat yadam ni sir okay then is electron, can you tell me, is electron a wave or particle? Landmark niko, ay su landmark niko, migi de oida biya ay landmark oinu, ay quantum mechanics adigi tamba hogi do niko. Adigi oza sina high consider electrons wave la particle high consider ay se. Tabung kang de. Haiga ko satrana khumba simaktabu ko su satro pani khangeba. Na khoina bhaiba khumba daga yam haiba mala na sum table se hek namat pamakai pressure pidan leibedo mado akoi su notice tawi adu ai ozaw bene to min leibi wani ai feasible lan bagi ko su ozaw tinga de disatro ya de oza sina hangma tam ko restless weba imana sura kan khuma gadi pe khumuk to gadi ko restless weba de hange is electron a wave or particle? So, I don't have any answer except this one. So let me guess. Okay, have your time. Ma'am, to me, question do na pin drop silence. I'm okay hen silent no hen grab. God, the atmosphere. I think is electron wave or particle? Is it to bungangre? And sir, let me guess. Okay, have your time. I think the kya can guess to do no. And so come there in I. I assume me can lolly can go as I do not paint you when I go. And I have, sir, electron is neither a wave nor a particle, but is simply an electron. Ma'am said, no ever. No from Sutupon, I should no ninganiva. I know Kumagi no pay at the one. Electrons a wave particle. Electron waves not there, particles not there, but is simply an electron. However, ma'am said, no eh. However, I, Sarsana, Santaway. However, okay, then it has to possess the duality of being a wave and particle. Harureba. Ozaduna kyam harawe. Yes, that is the right answer. Madugi no mitu dagidi ozasina takadaba parase. Hayenge ingona hankada khandana. I say, hey boy, I do quantum mechanics. Pong pa the park. Masishu in a quantum say, some like ye. Kayatare say. Intense number the peak the seedling to encouragement people don't talk here. Was I don't hang the Pakatana Yam single out tropodo, but the Queen Pakasagi Vitari. But do Magna I so hate I say, Masidi, see quantum irasida, Pusan Directana, pick a super number, and cutting share to Wangamba say, I am supposed to be blessed at all. But so there, but I'm say, what I'm saying, I'm going to 15 yagidro 10 minutes po yagidia okay then adigi ko sigi kanu se se akoi sigi kanu se phang matungda yare koi kanu se phange adigi matam sida nail borgi ko sisa Planck hypothesis fazaba yam yauri Planck kanu sida pirakpa matamda ko magi kano se theory si koina Planck na lawram mi se man established se swa hai atom constituting the source of thermal radiations Planck nam su pirami ba koina di kano gi Einstein gi gaitare sorry Bohr gi spectral transition formula do ai magi kano frequency rule do madu oiboning ma this mam harami ba se Rutherford planetary electron sing Rutherford ki mano to si Bohr gi kano si postulate se kudi mag sumi hydroga su ka tare se matam da khuna piri si microscopic le koi intention di kano macro da le do microscopic at the extent of your ka tare se atomic scales at the subatomic particles and atomic dimension la kum tan classical mechanics ki failure do la kun hydroga di we are supposed to entertain the validity of Bohr postulates and with physical evidences with the very concept of internally success of the atoms se koi nahi na ba whole air Rutherford matam se da Rutherford na pyramid si magi keno si kadai de la ke da Rutherford ne then Zeiger ne boku sing sina ko koi scattering of alpha particle tore from a thin foil of metal foil from metallic foils then scatter boku no sing sigi observe to matam da magi range of the nucleus the positively charged particle mayam and most of the my mass is concentrated the central region that is so name is your nucleus. Thomson gi padang method tagidi kitang deviate to thora ahama hu matung le si padang method watan ne Thomson's model du khatane then adigi si la matam da ku ke dore magi ke no se structure se atom ki kahta nuclear configuration almost of the order of 10 to the minus 14 meter somewhat agreeable to with microscopic version in a low hole then see hypothesis low matam da ko kaino na high Rutherford na sorum skeleton ide energy levels ide higher level energy ko E2 level sina E1 da sung dharak patar gadi ko matam sida ice into new one to say or new to one say does it E2 minus E1 oigadra na mana question of the rays of tore electromagnetic radiation mana to gadi sigi kano se emissions na te mana to rumade ko one rather matam se initiator si oigadra later on it was proposed or postulated through the Bohr postulates of electronic configurations or atomic configurations of atoms. Then, since Neil Bohr magi can order ko putu kumatamda ko sigi total energy of electron at a particular in this case you see the energy of the station level get ko tare se masse quantize over simayare then adigi ko mai ke lagtare se si rn means the radius of that particular arbitrary state ta quick water legada mage energy to madu kya manare it's supposed to be E minus of E square by I by epsilon naught into Rn yamna achoba ke no sing do I skip tore then matam sta ko magi RNC eko magi intrigue factor amale a note that is a note the Bohr radius ni and what the constant ni eko and the note the times of n square hiba relationship of the way all these rather happens to be in the midst of microscopic dimension the koi oi ngak tene bse eko microscopic dimension loi oi thokre then si matang sida magi keno se borna magi theory si am refine to no hone am magi keno se ko koi khare hena mas more kahitere se moderations magi hona basi am lepti ma matam do hona minery sing si kuna tasena haiba taraga di ko koi si jaga negative energy la isi mana si negative pi isi ko na budi conventionally attractive nature na pi bani na hariga su ko matam sida born logi ba concept te ke sunate ba electron ma hariba level do the gi ko tare se extract to gyar ga di ko tare se koi amount of energy khara ko tare se apply to we tai the positive energy uhendoi ni ko aduna apply to we have concept to negative conventions one explain to it but later on it should be modified as you see the energy so proposed is to be devised by your attractive nature of potential barrier and small logi then adu matung da gidi ko koi ke tare se nang yoji ke no se Bohr radius because almost compatible with that of 10 to the power minus atomic scale do da then adigi nuclear scale do da koi sang manga ke to mutam digi ko khange adi macroscopic dimensions to some extent koi appreciable we have said due iras de koi phang manga ma then adigi Bohr honori ba mayam se hona jarga su maga hona minery si Frank koi lay then mostly then adi ko te Bohr my colleague mayam sing sina ko nang hoji ke no topic sida yamna hena ko ni effort pi rega su yai ko mai ke no se khar hena much more complicated oiba adi say relative intensities of the spectral lines on the spectrum on the same spectrum aduma puthorok pa leidana koi structure fine structure element puthorok pugumba then adigi kano sing se khara hena loosen ba adigi hydrogen da applicable oirga su khare na heavier oiba atom sing si changsal pum tam da di ko matam da sumagi keno limitation khara leibugum torpa answer to bungam dana sumlerik pasina with the advent of your wave particle duality, the new concept wave particle duality, and with the introductions of your wave mechanics, I should say wave mechanics, Sorensen puthokiba wave mechanics to madu lakpa matam da gidi new keno se koi quantum mechanics ki anoba mayon se koi puthokpa ma pudong tawreba. It is at an around 1926 or something like that. Aduga aina sesa explain to the yaudriga su aina ko akoi dichotomy amaka sina all about this ko iradu da thopa concept ni aduga hauji tasen haiba taragadi quantum and classical keno se dichotomy leba adi contradictory di malaga tasen databa adi you see classical mechanics se ko quantum mechanics se machigi shorter wavelength long matam da ko sidi WKB method hoi kai koi yam yaura ani then adi ko tare se ray optics and wave optics sida su adum ko tare se quantum picture then adi wave picture se adum tholak ka dore ba tholak pasina ke so se keno don ta ka pa ai tak ti ta amaroi ko ana sina sumnagi just side extensions to this one sina kero tare se sina ko electromagnetic wave equations D'Alembert's electromagnetic wave equation. Then Maxwell has proposed to Boni, and here and represents the refractive index. And Sidana, sorry, the wave Lapumatamana, wave mechanics Lapumatamana, Sidana, variations, Siki say, Magi, refractive index the base story, Sidana, potential the base story. Then again, Hena. Ideal solution ma punano chikita ikan to reko ai article kan study biawi ana cd koi kan honi lagto WKB method ni lagto si phase ko se phase koi ki koi yamna first varying with ba aduga si amplitude na slow varying with ba aduga then adi kan do lei bangam drabra then adi ko sigi kan se magi sumnagi koi ki ordinary ko tare se magi wave form se plane wave form se lower si then adi ke wetare se momentum ma masana energy eigenvalue si lere then momentum eigenvalue si lere and correspondingly si pieces point are but in turn rather happens to be here p square twice m plus b of r equal to total energy the Newtonian mechanics adunadi matter gi wirisu then wave ki wirisu abanis de kelactare se samana ba idea madagi subject to the limitations of the understanding or pagum taweba eko asini all about this I slice the kitang I mathematically am yawmandana I kitang wind up tawre so that may am not make me excuse for this one and lastly not the least I di koidi university ojaragasu koidi constituent college lagi oirak pani now we have a better sense all about the syllabus of degree UG. Amarum da thabu wazaragasu we are lucky enough to have sense the visuality of both UG and PG syllabus. Ano kaya na professor nimana takpi bagum ko ay na kuire ay UG taksar pase almost 40 years complete usilakadore 1987 dagi taksar pani aduna sigi kaino se sisa ina thener pe experience ta koi lairiba UGC piriba criteria UGC piriba kudimok se well acknowledged we phajai adubo due to kaitere koi Manipur city mayam ga sumana de there seems to be a lot of limitations koi yamna freely agi will da koi kaitere se loima koi mechanized over se seems to be I don't know khangde ngamde habadi nuwaite ngamdabagadi chamanare yadi aduna like talking da parikha tausi habi culture sisu soida di khangde dum thonare yang wai aduna si matang da ina suggest toning basi ego from my own view niko you see quantum mechanics supposed to be break off into two lines or two parts one matrix mechanics and the wave mechanics. we really emphasize and mindfully discuss all about our wave mechanics, that is, Schrödinger ngaktan ekhoina urise. And rather, or apparently missing the very concept of the fairness of matrix mechanics. Heisenberg matrix mechanics extent lagging with male, and it should be nice and it should be perfect to make compatible with these very aspects. Koina salaro isi hairagadi khangdri aduna tragadi matrix mechanics e masigi lagging oiba perspective amadi ai adum thengna bagum tawi hairiba khoise ko matrix mechanics e yari koi tak tre manam dikano magi time bound labor then adigi magi syllabus tuna demand toruk tabani na koi sungam dre ha 6 months ki perase koi 6 months ki semester sida koi tak pangam de sina 1 year extension origadi koi suko matam nungai na phangani adu madu ngaksu koi apamang ta torga leibadi abanati ano. So there seems to be somewhat incompatibility between our wave mechanics and matrix mechanics, and the wave mechanics happens to be an ace over the matrix mechanics. And with these few words, let me wind up with my topic.
Thank you, sir. Any questions from the audience? Carry comment on the wall.
Okay.
Thank you very much
But,
for your detailed talk.